Welcome back. In this video, we learn about perceptron. A perceptron is the simplest type of artificial neural network which was introduced by Frank in 1958. Perceptron learning model is a combination of two concepts. It incorporates Meckel-Pitts model as well as Hebbian learning rule. The Meckel-Pitts model is used to represent an artificial neuron, and Hebbian learning rule is used to adjust the weights. This is a binary classifier which determines whether an input belongs to one class or another based on a linear decision boundary. The perceptron model consists of 4 steps. It represents the inputs. The next one is it represents the weights and bias. The third one is the net sum. The fourth step is the activation function. Here the inputs are represented as x1, x2, etc. to xn. The weights are represented as w1, w2, etc. to wn. The bias is represented as b. The calculation of net sum is based on the summation function, which is summation of I xi into wi, which is nothing but x1 w1 plus x2 w2 plus etc. to xn wn. This results the net sum, which is applied via activation function. The activation function most probably will be a binary step function. Based on the activation function and the threshold value, the perceptron outputs a y. So this is the mathematical representation of a perceptron. Now we look into the perceptron algorithm. The first thing is we need to set the initial weight values for w1, w2, etc. to w1, as well the threshold value theta between the range of minus 0.5 to 0.5. And then there are 5 steps. We need to do the 5 steps repeatedly till there is no error. The first step is compute the weighted sum by multiplying the inputs with the weights and add the products, which is nothing but x1 w1 plus x2 w2 etc. The second step is apply the activation function on the weighted sum. So here it's represented as the formula y is equal to step of x1 w1 plus x2 w2 minus theta, the threshold value. So here, as we are using the step function, we are mentioning the step here. Then if the sum is above the threshold value, output the value as positive, else output the value as negative. The next step is calculate the error by subtracting the estimated output value from the desired output value. So it is represented as error E of t is equal to y desired minus y estimated. After calculating the error, we need to recalculate the weight. So the weights are updated as delta wi equal to alpha, which is nothing but the learning rate, E of t, which is nothing but the error, into xi. Xi is the particular input I. Now we will get delta wi, which is the difference in weight that has to be added to wi. Now will be using this delta wi to add with wi. So our modified weight wi will be getting wi plus delta wi will be the modified weight. So these 5 steps have to be repeated again until there is no change in the output. Now we look into the difference between threshold and bias. the perceptron fires, that is, it outputs a 1 value if the net input is a non-negative value. What is a threshold? Threshold is represented as theta. It is subtracted from the weighted sum of inputs. It means that x1 w1 plus x2 w2 minus theta. It means that the perceptron fires if x1 w1 plus x2 w2 greater than or equal to theta. Now we learn what is bias. Bias is represented in terms of B. The perceptron fires if x1 w1 plus x2 w2 plus b greater than or equal to 0. Now we will look into what is the equivalence of the two forms. The bias as the negative of the threshold or vice versa. It means that B is equal to minus theta or theta is equal to minus B. The choice between using a negative threshold or a positive bias is primarily a matter of convention. In modern machine learning, the bias term is more common. It is often implemented as a weight on a constant input of 1. Thank you.